So, congratulations, you have registered for a very unique and very exciting event which we called National Anveshika Experimental Skill Test NAEST. As you know, this is an annual event of Anveshikas where we ask students to perform experiments and then evaluate them, and then you get all kinds of prizes and scholarships and this and that. So, there are 4 rounds of this test that you must have read from our website. The brochure is there, and the first round is screening round, and in which all the students who register appear, and from this we take some of them to this next round. Now, this screening round has a very different format from all kinds of tests that you might have appeared in your schools, colleges, boards, or different kinds of Olympiad examinations or different kinds of inter-school competitions or so anything. So, this will be a very unique kind of format, and therefore, this particular video that we are preparing is to get you acquainted what kind of questions will be there in your screening test, and how to look at it, how to think on it, and how to answer to it, how to think about it, how to approach these problems, such problems. So, this is the purpose of this video, and the general format is that we will be showing you a short videos, maybe few seconds or maximum 1 minute, let us say, and that will have some kind of natural phenomena or some kind of lab sitting phenomena, and from that video you have to observe the things very carefully, and based on that video there will be MCQ questions and you will be answering those questions. To give a live experience or more closer experience, we will be showing you some questions which we used in previous years, the corresponding videos, and then based on that I will be discussing that how to look at the video, how to run video, and how many times to run video, when to run video, when to read the MCQ question, how to think about it. All these connections I will be showing with respect to 4 questions, 4 screening questions that we have used in the previous years. So, let me go to the website and then discuss all those 4 problem sample questions that we have put there. So, this is the landing site. When you go to our NAEST website, you will be having this screen, and here is the home, and this is the home page. In fact, next tab is sample questions. So, I will click on this sample questions. You will also do the same to look at this video again and again. So, I will click the sample questions, and then you see this particular screen. Now, on this screen there is a window in which some video is playing, something is being done there, and on top you have these numbers 1 here, 2 here, 3 here, 4 here. These are question numbers, question number 1, question number 2, question number 3, question number 4. In the actual paper that you will be appearing, there will be something like 16, 17, 18 questions. So, you will have 1, 2, 3, 4, 5, 6, 7 and so on, all the numbers will be here. Then on the left side you have this question here, question 1, and then there is a description in English, and then you have description in Hindi, and then you have options here. So, this is one option, this is another option, this is option, this is option, this is option. So, let us look at the questions themselves. First thing is this video. This video you can run as many times as you wish, and this play button is here. So, if I press it to see what this video is, I will see that yes, there is something which is oscillating here. This is in fact banana ghor. This is banana. These are all bananas, and this whole thing we called banana ghor. And this is tied to a rope. You can see that. So, and then this whole thing is tied somewhere else, and then it is oscillating, is doing these oscillations. This is the video. So, you have to see the video, observe what is there in this video, and then read the question. Now, let me come to the question part. Question 1, look at the banana ghor, the whole thing hanging from the rope, oscillating. So, you have to look at the banana ghor which is oscillating, measure the time period of the ghor. So, here you are asked to measure. So, in some of the questions we will have this kind of measurements and you have to do the measurement. So, it is not only that you see the question and then answer the option, you have to do something, create your own number, create your own answer, and then match it. So, measure the time period of the ghor using your mobile stopwatch. The time period of oscillation is closest to. So, you measure the time period and then find how much is that time period, and it is closest to, and then you have option closest to 2.20 second, or closest to 2.25 second, or to 2.30 second, or 2.35 or 2.5 seconds. So, once you have your own number, you can just see which is the closest one and tick that option. Okay. I have understood the question, I have to measure the time period, and I will have to use my own stopwatch, mobile stopwatch. So, I have taken my mobile, I have opened that stopwatch, and with this I will be measuring the time period. Now, if I look at the question here once again, the options are time period 2.20, then 2.25, 2.30. So, the difference is quite small, 0.05 second in time period. So, that means I will have to measure it with a greater accuracy. So, if I go for say 10 oscillations, and the time period will be somewhere around this 2.20 or 2.25, like that, 2.3. So, 10 oscillations will mean something like 22-23 seconds. So, if I assume that I will make an error of something like 0.1 to 0.2 seconds in pressing the stopwatch to start and stop, this will be an error of 0.2 seconds in 22 seconds. Okay. So, that is a sizable error, because the difference is here quite small. In time period it is 0.05 second only, therefore, I need more accuracy. So, I will go for 20 oscillations. So, these kind of things you have to judge from the question and from the video, and then let me play the video again and to measure it. And as usual, I am ready with my stopwatch, and when this banana ghor will come to its left extreme, I will start the stopwatch and call it 0, and after that one oscillation 1, the next oscillation 2, I will measure it for the 20 oscillations. So, let me start now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So, it is 46.33 second. 20 oscillations, 46.33 second. So, how much is the time period? it is 46.33 divided by 20. So, that will be something like 2.316 like that. So, this is the kind 2.316 seconds, this is the kind. So, if I look at the options, I have 2.30 here, 2.35 here, and then the real value that I have calculated from my measurement is 2.316 or 2.32, and it is closest to 2.30. That means this particular option is the correct option, and you will choose this as your answer. So, this is one example where we have given you a question and also a task to perform, then you choose the right option. So, once you are done, once you have chosen the option, you can go to the next question. There are two ways. One is on this right hand top corner, you have question number. So, you can choose question number 2. You can also randomly choose 3 for anyone, but let us go sequentially. Or on the left bottom corner, you have this save and next. This is necessary. You have to save it, then your this answer is recorded. Once it is recorded, you can after that you can randomly go to any question, but here it is best to save and next. So, I click this and the next question appears. This is the next second question. Now, in the second question, if you read the question here, question 2, the video is the same as that in the previous question. So, it will happen. In some of the cases, we have one video and correspondingly one MCQ. In some other cases, we have one video and then there are two questions based on the same video, and maybe in some cases you will have a video and there are 3 questions from the same video, but each time you will get the video here on the right side and the question here. So, if you see that the video is same as that in the previous question, so you know the video, you can go to the question, and question reads, the video is the same as that in the previous question. The tension in the rope at its lowest end is denoted by T, and the weight of the ghor by mg. Now, you have to choose the correct option. There are some options. See the video again. Tension in the rope at its lowest end. Okay. So, in the video, here is that rope, this is the rope, and here is the lowest end where it is tied to this ghor. This tension is capital T, and then the weight of this whole thing, this whole ghor is capital mg. So, this is the situation, and then your options are, first is T remains the same in all parts of motion, यानी पूरी गति के दौरान T कैपिटल T एक समान रहता है. So, you have to look at the or calculate or find or guess something of the for the tension. So, how much will be the tension, and then whether it will be greater than whether it will remain constant throughout the motion or not, that is your first option. Your second option is T is less than mg at the extreme positions of the ghor. When your ghor is at the left extreme or at the right extreme, that time T is less than mg. This is the statement. You have to find whether it is correct or not correct. Similarly, the third option, this option here is T is maximum. This tension is maximum when the ghor is at its lowest position, and then mt is greater than mg at the lowest position. So, it is all tension and mg. So, you have to find how the tension will vary or it will not vary during this motion. So, let me show it on the board. So, you can take a simpler situation of simple pendulum, and the same behavior will be there for this ghor also. If you have a pendulum and this is an extreme position, this is the mean position, this is the lowest position of the bomb, it goes in a circular path. So, this is one extreme position and then this is another extreme position. So, this is that circular path. The tension here is T and weight here is mg, anywhere in this whole oscillations. So, let me first talk of the extreme position, one of the extreme positions. So, here since it is going on a circular path, you must have a radial acceleration, but how much should be that radial acceleration, the component of acceleration towards the center and towards this radius, that should be v square by r, where v is the speed. So, tension is this direction and the component of mg in this radial direction, I am interested in the radial direction towards the center. So, this will be minus mg into cos theta, this angle is theta here. This is the net force towards the center and therefore, the acceleration towards the center will be this divided by mass. So, this divided by mass, this is the acceleration, component of acceleration in the radial direction, and this should be equal to v square by r. If something is going in a circle of radius r, then the acceleration towards the center is v square by r. Now, this v is 0, this is extreme position, v is 0. Since v is 0, this is 0 and therefore, there is no resultant force in the radial direction, no component in the radial direction. So, T is equal to mg cos theta. This is at the extreme position. If you are here at the lowest position of this ball, then mg is here and tension is here and it is going tangentially with some speed v, which is the maximum speed in fact at the central place, equilibrium place, the speed is maximum. So, this equation, and of course, cos theta is 1 here. So, for the lowest position, you have T minus mg, this is the radial force in the radial direction. This is the force in the radial direction, T this side, mg this side. So, T minus mg and divided by m. This is the acceleration and this should be v square by r, and this time v is not 0, here v is not equal to 0 and hence you have T is equal to mg and plus mv square by r. So, the tension was mg cos theta at the extreme position, which is less than mg, because cos theta is always less than 1. So, T is less than mg here, but T becomes more than mg here, T is mg plus mv square by r, v is picking up. So, there is some finite speed here. So, T is more than mg, and then again it will reach here, then here again T will be that same mg cos theta. Okay. So, the tension increases, becomes maximum here, then decreases. This kind of analysis you have to do, this kind of physics you have to show your competence in analyzing the situation using the physics principles that you have learned. Now, let us go to the options once again. The first option is T remains the same in all parts of the motion, wrong. T is less than mg at the extreme positions of the Ghor, yes, T is mg cos theta. T is maximum when the Ghor is at its lowest position, yes, and T is greater than mg at the lowest position of the Ghor. So, that is also true, right. So, the first option is wrong, T remains the same in all parts of the motion is wrong. T is less than mg at the extreme position of the Ghor, correct. T is maximum when the Ghor is at its lowest position, yes. T is greater than mg at the lowest position of the Ghor, yes. So, 3 options are correct. So, in our questions, one option may be correct, two options may be correct, three options may be correct, four options may be correct. If there are five options in some question, maybe all five are correct. Any number of options are correct. So, this is how you have to think, you have to calculate, you have to choose the options. Now, next question, save and next. So, we go to next question, third question, and there is a plastic scale, there are two shining cylindrical things, and gradually one is being taken closer to the other one seems to be fixed, and on the plastic scale you can see the separation, and somewhere here up to here nothing very exciting. They are holding with the fingers and then releasing step by step, and here when they release it just goes and sticks to the fixed one, and this is a pin box which is being placed here. Okay, so that is the video. Now come to the questions. You have seen the video, come to the question, and then if needed go back to the video as many times as you wish. The question is, the first part of the video shows a fixed magnet A. So, this magnet which is here, and that capital A was written there, if you wish we can again do. So, this is capital A. So, this is magnet A. So, the first part of the video shows a fixed magnet A and another magnet B, this is now magnet B, and it is being brought closer to it. So, it is being closer to this magnet A, and then choose the correct options. So, this distance also in centimeters, this is 1, 2, 3, 4, 5, okay, 6, 7, this is around 7 now, and around 7 centimeter it just goes towards this. Now, your option is the magnetic field at A, magnetic field of A is 0 at distances more than around 7 centimeter from this pole face. So, the magnetic field of A is 0 at distances more than around 7 centimeter. When the distance was more than 7 centimeters like this, you can pause the video also, so you can pause anywhere. So, if I pause it here, then this distance is more than 7 centimeter, and when it is released it does not go anywhere, okay, it does not go anywhere. So, it may seem that the magnetic field of A is 0 here, is doing nothing to it, but that is not true. You know it, you have a magnet, then you have magnetic field at all the points. Because of this, if distance is large, the magnetic field becomes smaller, maybe much smaller to show any visible effect, but the magnetic field is always there. So, this option is wrong. The magnetic field of A is 0 at distance more than around 7 centimeter, that is wrong. The acceleration of B between its release and hitting the magnet A is constant. When it goes and hits here, that means if you run the video around 7 centimeters, when it comes to around 7 centimeters, then when it is released it just goes and hits magnet A. Now, in this period after releasing, when it goes and hits the fixed magnet, the option says, the statement in that option says that the acceleration of B is constant. Okay. Now, as it goes, as the magnet goes closer, the magnetic field will increase, the force will increase, and therefore, the acceleration will increase. So, this is also wrong option. that acceleration of B between its release and hitting the magnet is constant. छोड़े जाने से लेकर चुंबक A तक से टकराने तक चुंबक B का त्वरण अचर है. This option is also wrong. Now this is the velocity of B between its release and hitting the magnet is constant. That is also wrong, because as it goes closer, then the traction force is larger, acceleration is larger, more and more acceleration. So the velocity cannot remain constant. Velocity is in fact 0 when we released, and if it is constant, it will just stay there. Okay. The last one is the poles of the magnets facing each other are of opposite nature, north or south. दोनों चुंबकों के ध्रुव जो एक दूसरे के सामने विपरीत प्रकृति के हैं, या तो उत्तर दक्षिण में विपरीत प्रकृति के हैं. That is of course correct, because you see you have an attraction. You have an attraction, and unlike poles, when they are close to each other or facing each other, they attract. So this is the question number 3. We can go to question number 4 after saving the answer. And if you go to question number 4, it says that the video is the same as that in the previous question. The next part of the video, in the first part you saw that acceleration and magnet hitting. Now the next part of the video, which is on your screen, paused this time, shows a paper pin box placed in front of magnet A. So this is magnet A. In front of this magnet A, this pin box is placed, assuming that the north pole of A is facing the paper pin box. North pole of A is facing the paper pin box. So this is north pole. You have to assume that this is north pole. Okay. Now option, the paper pins become magnetized. Yes. With south poles towards the magnet. Yes. If you have a magnet, north pole here, it has a magnetic field, and then you put this pins here, then because of this magnetic field, it will be magnetized if it is ferromagnetic material, and the direction will be in the same direction. So if this is the north here, south will appear here, and north will appear here. So the paper pins becomes magnetized with south pole towards the magnet A. Yes. This option here, the magnetic field at points between A and the paper pin increases. If you have a point here, if this paper pin was not there, there was some magnetic field here. Now because of this paper pin box, the magnetic field has increased, because this magnet, all these pins become magnet, and they also produce magnetic field in the same direction, the south pole here, north pole here. So the field direction here, because of the pins, will also be in this direction, and already you have magnetic field because of this in this direction, north pole here, and so it will add. So this option is correct. The magnetic field at points between the magnet A and the paper pins has increases. Yes. The paper pins become magnetized with north pole towards the magnet A. They become magnetized, that is okay, but with north poles towards the magnet A, that is wrong. This is south pole which will be appearing here. So this is the wrong option. Then the magnetic field at points between the magnet A and the paper pin box decreases. So that is also wrong. We have already discussed, it increases, not decreases. So this option is also wrong. So the two options are correct here. This is how you have to think, you have to analyze, you have to use your physics knowledge, your equations, your understanding of the things to get the right options, and mark all the right options which are there and do nothing to the rest of them. If you mark an option which is wrong, then there will be some negative marking. If you do not mark a question which is right, then of course you lose the opportunity, you get 0 for there. So this is how you have to see all the questions. You will have some 16, 17, 18 such questions, and with videos On each video we will have either 1 or 2 or 3 questions. Analyze it, do it, you will enjoy, because all these situations which we show here, they are also specifically designed for you. And all the best. Thank you very much.